ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ವೈರ್ಲೆಸ್ PSI ಕರ್ನಾಟಕ ಪ್ಲೇಲಿಸ್ಟ್ ಅಲ್ಲಿ ಇವತ್ತು ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಿರೋದು ಸ್ಪೆಷಲ್ ಟೈಪ್ಸ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆನ್ ನಂಬರ್ಸ್ ಅಂತ. ಸೊ ನಂಬರ್ ಕನ್ವರ್ಷನ್, that is in digital electronics, we have discussed lot of questions. Okay, so if you have seen all the videos which I have uploaded, that is our wireless PSI Karnataka playlist, then you could have seen some 10 videos regarding number conversion, problems on numbers, and what is the mean by. Okay, so all the things basically we have covered, but in this session I personally want to do some problems which are very unique, and these type of problems we have not solved already. Okay, so that's why these are kind of problems which are like tougher one. So normally these type of problems are not asked in competitive exams, as they will as the students will be facing difficulties in solving these type of questions. But if in case if they ask, because who know, if the question paper setter wants to make the question paper a more little bit trickier, then he can add these type of questions. So he has got an option of adding these type of questions, so that's why we should be prepared. So keeping in that one in mind, we have just prepared a material where we will be solving some 4-5 problems which are very unique and very different from the problems which are already solved. So that's it for the intro, and let's start the video with first problem itself. Okay, so problem number one, what is this? A decimal number 214 is given. Find the octal equivalent for this one. So they have given a decimal number and they are telling that find the equivalent octal number. So this you can do with the help of two methods here. So first method you can do is just take that number 214 and divide it with the help of 8. So you can 8 2s then 8 6. So 8 26 208 and we will be left with 6. So next what you will be doing, 8 divide 26, that is take this 26 and divide it again with the 8. So 8 3s are 24 and we will be left with 2 here. Then again 8 and take this one 3 here and divide. So you can't divide this one, so you can take a 0 here. So I will just put a 0 here, so that it says you can't divide because 3 is lesser than 8. So you will be having like these 3 bits here. So reminders that you will be using. So this is the MSB and this is LSB. So you will be moving from MSB to LSB. So that one is somewhat trickier, but the same thing can be done like this. So see, this one I have already explained, I think. So that's why it will be not tougher for you. But believe me, this is asked many times in the exam. So 214 you can just divide like this. So I have already shown you all those problems. So a lot of problems I have solved on this one also. So 8 2s and 8 6. So you will be left with 6. Then 8 3s 24. You will be left with 2. Then 8 0, because I can't divide this one. So I just put a 0 here. Or else I can stop at this moment. So I will be writing from down to, so that is NSB to LSD, sorry, digit, and 3 to 6 I can write. So 214 in decimal when converted to equivalent octal number, then it will become 326. So I have already told. So whenever decimal number is converted to octal number, its value will increase. So here you can see 214 has become 326. So the value has been increased. Okay, so the second problem. Alright, so now I think this is somewhat trickier. The decimal equivalent of 614.15 to the base 7 is. So if you see here, this is given in point, and moreover the base value is 7. So we have seen a base values of 2, that is binary, 10 that is decimal, 8 that is octal, and 16 that is hexadecimal. Now what is happening here, they have given the base value as 7. So what the hell is this? So let us try to find out how we can solve this one. Okay. So n equal to 614.15 to the base 7. So how I can convert it to the equivalent decimal form? So you can see here, this is the formula which you should apply. So the same thing which we will be using for a conversion between decimal to octal, that one will be here. That one itself we will be using here also. So you can see here 6 into, so from dot if you move towards left we will be having positive numbers, and if you go towards right, we will be having negative power. So you can see 6 into this one will be having 7 to the power 0, 7 to the power 1, 7 to the power 2. So we will be having here 7 to the power 2. That's why I multiplied this one. Then plus 1 into 7 to the power 1 plus 4 into 7 to the power 0 plus 1 into from dot to right, we will be having negative number. So I will be writing like this. From minus 1 it will be starting. If you are moving left, then it will be starting from 0. But if you are moving towards right, then it will be starting from minus 1. So I can write 1 into 7 to the power minus 1 plus 5 into 7 to the power minus 2. So I just simplify these things. We will be getting 294 7 plus 4 plus 0.142857 plus 0.102. So when you add all these things together, we will be getting 305.24486 to the base 10. So this is the answer which we will be getting whenever we convert this particular base 7 value to base 10, that is decimal equivalent. Alright, so we move to the third problem now. The hexadecimal equivalent of this particular binary sequence is. So they are given a binary sequence and they are telling to find out the hexadecimal equivalent of this particular sequence. So what is this? 1 1 0 1 1 0 0 0 1 0 0 1 1 0 1 1. So if I want to find out the octal, then we will be grouping the binary numbers in a group of 3 digits. But if you want to find out the hexadecimal number, then you have to group the binary digits in the groups of 4. So the same thing I will be doing here. You can see here. So first I will be starting from right and we will be moving towards left. So first 4 elements I will group them together into 1 digit. So you can see here 1 0 1 1 will be the first group, then 1 0 0 1 will be the second group. You can parallelly observe here. Then I have covered 1 0 0 1, right? So 1 0 0 will be the third one and 1 1 0 1 will be the fourth one. So the same thing I have written here. So first group, second group, third and fourth. So if you remember the mapping between decimal and hexadecimal, and if you have not seen that video, please check the playlist what is meant by hexadecimal number system and hexadecimal to decimal conversion. You should see those things. Okay, so check the playlist, you can find the videos. So lot of stuff has been already uploaded. Okay, so 1 0 1 1, what is this? It will be 11. So that's why its value will be hexadecimal equivalent value will be B. And for this one, that is 1 0 0 1, it will be this will be 8 and this will be 1. So 8 plus 1 9, and 9 I will be writing in hexadecimal and decimal the same thing. So that's why I can write it as 9 itself. Then if I go for this particular digit, that is 1 0 0, so this is 8 and on none of the other bits are 1 or high, so I can't add anything to this one. So it will be merely a 8 value, so that is decimal value 8. So this is also less than 9, so I can write it directly, because hexadecimal and decimal mapping will change whenever we move above the 9. So it will be starting from basically 10. So A equal to 10, B equal to 11, so like this. That mapping we have to remember. Then for this one it will be D, that is 13. Okay. So this will be clubbing them together and we will be writing the answer. So D8 9B will be the hexadecimal equivalent of a particular sequence which has been given in the question. So we'll move to the fourth one now. Right, so a decimal number 0.1289062 is given, then the hexadecimal equivalent will be. So they have given a fractional decimal number and you have to find the hexadecimal equivalent of that one. So how I can find that one? So let me just show you how. So this is very simple, guys. So you just take the fractional decimal value which they have given, then you just multiply that one with the help of 16, because we are converting it to the hexadecimal equivalent number system. So for hexadecimal we know the base value is 16, so that we will be multiplying with 16. Okay, so I will just multiply with 16 and we will be getting 2.0625. So this also we have already seen, but I'll just explain quickly. So integer value will be taking, and the fractional value whatever is left, we'll just replace this integer with 0, so that it will become 0.0625. This will be taking here, like this will be taking. Then again multiply with 16, 1 is integer, again so 0 is left. I need not to multiply because it will anyhow become 0. So that's why I will stop at this moment and I will be having these two numbers here. So you can see from left bottom to top I have to read. So 1, 2 is the answer for this one. So that's about this particular problem. That is I think fourth one. Now fifth one. Okay. What is this? If 225 to the base x is equal to 341 to the base 8, then value of x will be. So see how they are given now. So they have given the equivalent number conversion, but they are not given the bases here. So one base is given and two numbers are given. We need to find out the second base. Okay, so what will be the base value for this one? So this is very simple, guys. So if you approach with this method, converting octal to decimal. So if you convert this octal number to decimal, we will be getting the equivalent base value. So octal how I can do? So you just multiply with the octal number. So 3 into 8 to the power 2 plus 4 into 8 to the power 1 plus 1 into 8 to the power 0. So I'll be getting 225 to the base 10. So this is equivalent, and when you solve this one, we'll be getting x equal to 10. So this base value here we'll be getting. Okay. So that's about this particular problem. Now we'll just move to this next problem that is of same kind, I think. Okay. The same kind of problem has been asked again. So just observe this one. What is the base value of x here? So if this mapping has been given, then 193 to the base x and 622 to the base x. So previous problem we have done directly. So the method which I have employed is this one. So you can just use this one and try to solve the problem which is already on the previous to this one. Okay. So convert octal to decimal as usual. So 6 into 8 to the power 2 plus 2 into 8 plus 3, because 8 to the power 1 and 8 to the power 0 will be there. So I have not written those things because it will be like a repetition for many of you and you will be bored. So I don't want to do that thing. So that's why I have not written. Okay, so it will become 403 and I can write now. So this thing has become 403. Then what I can write, 623 to the base x will be equal to 403 to the base 10. So this thing has become this one. Now what I will be writing, take this. Okay, so it is not base 8, it will be base x. Okay, so 193 to the base x will be equal to, so I can replace this with this 403 to the base 10. So I can replace like this. So that's why 193x. So this I will put it as it is, but for 623 I will be replacing it with the decimal equivalent. So that is 403 to the base 10. So what I can do now? So just apply the same thing, 1 into x to the power 2, because x to the power 0, x to the power 1, x to the power 2. So that's the formula. Then 9 into x to the power 1 plus 3 into x to the power 0, which will be equal to 403. And when I further try to calculate, simplify this one, then what I will be getting, okay, x square into 1, x square, 9 into x, 9x, plus 3 into x to the power 0 is 1, so 3 into 1, 3, okay, 403, x square plus 9x plus 3 is equal to 403, and when you solve this quadratic equation, so that is whenever you multiply those two numbers, you will be getting like 3, and then you will just remove this 403, so you will be left with 400, so minus 400, x square plus 9x minus 400 will be equal to 0, so we will be getting these two roots here, right? Basically 16 and minus 25. So in next session I will be telling you how to solve the quadratic equations, because if I mess these things together here, if I club them together, then you won't understand both. So that's why you just keep a track. I will just explain you in the next video how to solve this type of quadratic equation. So I hope you will be knowing, but if you don't know, don't worry, just check the channel after some time, or else at this time, if you whenever you are seeing the video could have been uploaded also. So just check, just make sure you check the playlist, guys. Okay, you will get everything there. Okay, so then conversion from fractional decimal to hexadecimal. So based on this one also we have a problem here. So how I can do that one? See, a decimal number is given as 22.64. Then find the value of hexadecimal equivalent. So decimal value is given as 22.64. So find out the hexadecimal equivalent. So how I can do? First step, we will be taking the decimal part only. So take 22 and divide it with 16. So 16 ones are 16 and I will be left with 6. Uh, so I can write 1 6. So that is MSD to LSD. Okay. So then I got for 22 I have got a hexadecimal equivalent 16 to the base 16. Okay, now fractional part I will be taking. So that is 0.64 is the fractional part. Okay, so into 16 I will do first. So into 16 when I do, I'll be getting 10.24. So that is, I will just take the integer part as a carry, 10 equal to, so 10 I can write in hexadecimal as a. Okay, so directly I have done. So, and then I'll be taking the part 0.24. So again I will be multiplying it with the help of 16. So then I will get 3.84, where 3 is the integer and I will take it as a carry. So 3 will be equal to 3 in hexadecimal and decimal. So don't need conversion here. Then 0.84 will be left. So again multiply with 16 will be having 13.44. So you can do it for some 2-3 digits. What is the accuracy? So if they want 3 digits accuracy, then you can do 3 steps here. If they want more than 3 digits accuracy, then you can go for 4 or 5 steps. Okay. So depending on the options, you have to decide whether you want 3 digits accuracy or 4 digit accuracy or else 5 digit accuracy in some cases. So normally it will be 3 digits, but for now I have solved for 4 digits. Okay. So you can see here, like this we will be doing until 4 digits we will be obtaining here. Then the hexadecimal equivalent will be, I have got previously 16, then in front of that I will be writing A3D7. So this is the hexadecimal equivalent for fractional part. So these are the sum of problems which are very important for wireless PSI Karnataka. So I hope you like this video and found this useful. Please guys, leave a like for this one because it has got a value with this. Okay, so share this video with your friends if they are preparing for the same exam. And thank you guys, thanks for your time. See you in the next one. Namaste.